Hi, and welcome to this AI and C# video on the Microsoft Agent Framework, and in this case, the 4 types of Foundry agents you can make up in Microsoft Foundry AI.azure.com. So we have covered option 1 a ton of times in these videos, and we have covered prompt agents, which is also called declarative agents, a bit, but we have never actually covered option 2, Foundry agents and hosted agents. And especially the hosted agents had been a big confusion, at least to me, compared to what it is compared to the prompt agent, and what 2 and 4 actually are different, because they look very much the same. But let me go through all 4 of them so you get the better understanding of what you have for options. So the first one, fairly simple. We have done this literally 100 different times in previous videos, where we go in and use the NuGet packet azure.ai.openai together with the Agent Frameworks OpenAI package, new up our AI client, Azure OpenAI client, with our OpenAI endpoint and either an API key or Azure default credentials or Azure CLI credentials, meaning RBAC. Once we do that, we can take that client and turn it either into a chat client or a responses client, which we then turn into our AI agent with instructions, tools, just like we do middleware. All of that works in general. The same for every one of these, because it's only the definitions that are different. And then we can ask our question or send our message. So nothing new here. Foundry agent is a kind of newer way of doing the same thing, but we're doing it against the endpoint instead of the Azure OpenAI endpoint. So as we look up here, if I get rid of these, we can see we use the Azure OpenAI endpoint in order to use the default direct model usage with our API key. But now we can also use the project endpoint. So we need a Microsoft Agents AI.Foundry, and instead of making an Azure OpenAI client, we now make an AI project client, meaning an AI Foundry project client. And here we use the entire endpoint for the project as well. And the special thing about this one is it has no API key usage. It needs to use RBAC in the various different ways you can do that, Azure CLI client and so on. For that reason, it's a bit slower to debug, but you get all the benefits of RBAC, which you could also get with Azure OpenAI, but this is just a slightly newer way of doing the same thing. Then you just take the project client and say as AI agent, put in your model, your instructions, tools, and you can ask the same. So these are very much the same, as you can see, just with a different client. This is what Microsoft actually do in all their samples, mostly because they don't want to expose an API key. So it all depends of, are you in favor of API keys versus RBAC? So far, these have been very simple. We're just pointing toward a model and using them in Agent Framework. Now comes the 2 other types of agent, prompt agents and hosted agents. And they are defined and then live up in the Azure portal. If we went and looked for anything with Azure OpenAI, we wouldn't find an agent up here. That agent was only in memory, and the same for the Foundry agent in step number 2. Prompt agents actually live up here, and you can go in and say new agent and build it up in code here, and it will give you this GUI where you can choose your model, you can choose your instructions, there can be tools and all kinds of things. So you can actually build such an agent up here without any code. And then you need to, of course, have some code that actually executed in Agent Framework. But it is possible, but we can also build this in code. So let's see that. We need the Foundry NuGet package again, just like the Foundry agent. We still need the same AI project client. But instead of just saying as AI agent, meaning an in-memory, we now make a agent definition where we tell the model our instructions and various different tools. Be aware that these tools are not the normal AI tools we usually do, but something called response tools. And if you have an AI tool that you need to put in here, you need to tell it to say tool.asOpenAI response tool, and then you can get it in here. But here you can also add the web search tool, the code interpreter tool, and so on and so forth. Once you have your definition for your agent, you then go and say project client.agent administration client.create agent version. Then you give it a name, and this name needs to be unique for your project because it's actually the primary key of what you saw up here. These need to be unique and end up being here. So when we do that, we can do that. We put in our creation options, which is our definition, and we can then say we want our AI agent as a result of that creation. We can also just say as AI agent with the name once it's created. So we don't need to create it every single time. And if we create it with different options here, we will end up with various versions, and you can actually go back to previous versions. So there's a kind of version control in this. And the way you build this is fairly simple. And again, even you can do it without code. So what you do in this area, you can actually just do up in the portal and then just say project client as AI agent with a name of that agent, and you will be able to run with it. So that's prompt agents. Prompt agents were first. There was actually a previous version called classic agents or persistent agents, but this was the new version that came along that had the versions. So Microsoft iterated on having these persistent agents up in Azure. And while these were okay, me and many other people complained a lot about if the portal couldn't do it, if the SDK couldn't do it, we couldn't really use anything new. We couldn't use A2A. We couldn't use any kind of special feature that was not yet exposed. So for a long time, for example, effort level could not be set on these agents because the portal didn't support it. So a lot of people have complained that while these are powerful, and one of the things you get by this is you get automatically traces of everything. It stores everything about what happened and for every single call to the agent. Lots of evaluation and monitoring in general we get by these, while the other ones, the ones in memory, we are to take care of that. But in our case, while this is good, we don't want to be limited by what this model, what this portal can do. And for that reason, Microsoft made hosted agents. So hosted agents are a little like prompt agents, but they are now hosted, not controlled by the portal, but just hosted, meaning it's your code running up there, but they host it and wrap it inside the portal, so we get the traces and the monitoring and all these things without the portal itself needing to know anything. It's just a middle layer between your agents that can then do anything and the portal itself. These agents can't, if you go into new agents, you won't be able to make one of these hosted agents because it requires code. So they just look like this, and you can actually just download the source code of the agent, which we'll see in 1 second. But you get the traces, monitoring, evaluation, all those things. And it also exposes it as a responses API specifically for that agent, meaning that up in the portal we have this endpoint. But if I go into my hosted agent here, it will actually have a dedicated endpoint. I go up here and show it. You can see we have an agent that have its name built into it instead of just the raw agent. We will talk a little about the hosting model and the cost at the end. But how do we then make these? It's actually a multi-step process. The first step is that we need to use both Microsoft Agents AI Foundry in order to define these agents, and Microsoft Agents AI Foundry Hosting in order to make a small hosting package, meaning a DLL in our case, that can be run on the behalf of AI Foundry. So the first thing is to actually make a small agent. And you do that in a different project where you essentially just do the same as an AI Foundry project agent, but we get the Foundry endpoint injected into us using environment variables, and we also inject our deployment model. We technically don't need to do this, but this means that they can be sent to multiple different Azure AI projects and use multiple different models. But we could hard code them here as well, and it would still work. And then we do our AI project client as an AI agent, just like we saw in option number 2 of the 4 we have. But then we go in and make an agent host and add Foundry responses to that agent host and register the responses endpoints. So this by itself, if you run that F5 on your local machine, you will actually get an endpoint, which is a responses endpoint that you could then call from something else, Postman or another piece of code, as if it was an OpenAI responses API endpoint. But this is just the code you need to build. You also need to take this code, or actually the source code of it, and deploy it. And this is where it becomes a little more tricky, because sending that code or the source code to AI Foundry, meaning getting it into this file here, and if we download this file, I can show you that inside it actually have the CS file and my program.cs, because these hosted agents will actually on the fly build my code and expose it in an app container. So we need to give it the source code, and in order to do that, we need to tell how is that container going to run, what is it going to run, and what is the code here. So we're going to build an agent with a name, my hosted agent. That makes sense. And we're going to make a hosted agent definition where we need to specify how powerful should this agent be, what CPU should have a CPU normally, an entire CPU dedicated to it, or 2 CPUs. That's the 3 options you have right now. But I've just given it the smallest, which is a half CPU. And then we need to give that container some memory. And in my case, I'm giving it 1 gigabyte in order to run this specific endpoint. Again, this can be done using some YAML and some Azure CLI, but if we want to do it by code, this is how we do it. Inside, we need to tell how the code configuration is. So we need to tell it's .NET 10 in this case. And my DLL, the one I made here, is called my hosted agent.dll. So I need to tell it that it's .NET that needs to run this DLL. And in this case, it says it needs to do a remote build with dependency resolution. We also need to tell what kind of endpoints this agent should expose. In this case, we are exposing the responses endpoint, but it can also do something called activity endpoints and interactive endpoints with the webhooks, but that's beyond this video. We can then on the fly give in environment variables. Here I've just hard-coded it here, but we could also just leave this empty and define it up in Azure after the fact. So this environment variable will actually be in one of these as the name and the value. So that is possible to do as well. And if we go in and set other environment variables, it could be environment variable to a connection to a rack system or database or anything that the source code needs, the code here, we could give it extra here as well. We need to define this as the metadata of the definition. And then we do a project client with the normal connections. And we then create an agent version from code where we tell this is the agent. Here's the file path to where the source code is. And here it's very important that you get rid of any bin and obj or launch profiles or any other kinds of files. It can only be the CSPROI and the CS file. I think they have chosen that because that's essentially what goes into a Git repository. So you could point it to a Git repository, download that, and say this is what we go in. But if there's a bin or obj file, it will actually fail deploy. We create that, and then we begin to wait, because what it will do, this method here, will actually be that it will create a Docker image. It will spill out of a container service, and it will deploy it as a test, at least. I will explain what I mean by a test. But once it's been deployed, it's evaluated all the source code that it can actually build it and host it. It will come back and say, now that version of the code is active, and we can continue. And the continue will, normally we could just say, now get me the agent. But in this case, since we had that special responses endpoint, we need to instead go in and say project client.project OpenAI client and get the responses endpoint that is specific to that agent name. If we just took the agent itself and try to use it as an AI agent, it will actually come back with an exception saying, a hosted agent, you can't do it like this. You should use the project, the specific endpoint for that agent. So we need to do this little extra step in order to actually get the agent's specific client, and via that we can make our normal chat client agent or AI agent and ask our question. So these are the four models, and there's a lot of information here, so I've just put it up in a little summary here at the end. So we have our four options: Azure OpenAI, Foundry, Prompt, and Hosted. And I will talk a little about why one or the other is best. So in terms of NuGet packages, they roughly use the same. This technically uses an extra, the Foundry by itself, because there's two projects now. There's the one that creates the agent and the one that is the agent. So it's a little more cumbersome over here in general. Prompt agents are okay if you can live with what the portal can do. I often can't, so I tend to not use those. And these two is all about if you want to use an API key or if you want to use RBAC. I tend to use this over here, but I could just as easily gone here, so that's more this came first. To me, it doesn't. I don't see API keys as security risks, but if I did, I would definitely go with the Foundry agents. So a proper modern day system would probably use Foundry agents all the time. It can just be annoying if you are multiple people on the same project. The type is essentially what we just saw, that Azure OpenAI agents and Foundry agents are direct model usage, meaning the agent is defined in memory. When your process dies, your agent dies. There's nothing saved or anything. And if you need to save anything or do traces or anything, it's your job to do that in your code. The prompt agents are persistent, so they keep track of everything, keep track of the previous conversations there have been, so you don't need to care about that. So that is definitely a nicer way if you're okay with having a little more cumbersome setup. Deployment, well, it is custom code, so you can deploy it anywhere in a internet information server on your local machine running F5 in an Azure Web App Service container app. You can put it anywhere in the world. Foundry agents, exactly the same. It's just in memory code. The prompt agents are actually the ones that are the easiest and also actually the cheapest, because you actually don't pay for them being hosted up in ai.azure.com. There's no fee for having them there, it seems. I couldn't find any, at least. Of course, you pay a little for storage accounts and stuff like that, but that is pennies. So it is actually a fairly simple and easy way, but with the limitations of what you can actually define up in the portal. Hosted agents are put into container images. So you create them either via source code, that we saw, or you can make some Docker images and then use the Azure CLI in order to send it up into the portal by itself. I've heard there's some bugs, and when I researched this a couple of months ago when it was very new, it also didn't work. So there is some issues there, but the source code, as we just saw, definitely works. But there is some container images, and that will actually also induce some extra cost, which we'll talk about at the end. In terms of protocols, it's essentially user defined because you can wrap a responses API or chat client around whatever you wish to do. The same goes for Foundry agents because you're in full control. The prompt agents, when you just get them out of the portal, they come back as responses API, but they can be exposed as Microsoft Teams or Microsoft 365 without you writing any additional code. So you can essentially make one of these agents and have it hosted inside Microsoft Teams without you needing to do anything. They are working on exposing them as A2A. It's in preview right now, but if you are into agent-to-agent framework, then there is options slowly. But again, a month ago, it wasn't there, and that's one of the drawbacks of this option. Hosted agents can do responses API, activity, just with Microsoft Teams and so on. It can also do invocation. I haven't tried it out, but it can do something with WebSockets directly instead of REST APIs. And it also have A2A. So you are fairly open in what you can do because you control the source code, but there is still what kind of protocol you expose it to is defined by the portal itself. A2A is also here in preview, but have most of the protocols here. AGUI is definitely the one that is missing in my opinion. We move on to security. The old Azure OpenAI can use both API key and RBAC, which is nice that you have that choice, while the other ones only works with RBAC. So if you haven't given someone access using Microsoft Entra, you won't be able to let the other people use the agents. Of course, if you just put in a web service, put in a custom login information onto it, you can have the server itself be the RBAC, and that's it using normal Microsoft identity. But if you need to be able to have that the specific user logging in is can be identified, Entra ID is the way forward. Observability, meaning traces, telemetry, all kinds of things. That is what you get for free inside the prompt agents and the hosted agents, because it's a wrap around the agent itself. While if you go for the Foundry agent or the Azure OpenAI agent, you need to build something custom. Agent Framework helps a lot with this, of course, but you still need to do it yourself. You need to put in the OpenTelemetry ID, put in a application insights or whatever you wish to do. Finally, we have cost. The first three are very easy in that you pay for your token cost and you pay for your hosted tool cost, meaning the web search tools, the code interpreter tools, and so on and so forth. Your own tools in your code, of course, you don't pay for with other than tokens. Hosted agents also, you need to pay for that, but you also need to pay for the usage. So for each virtual CPU hour, you need to pay this 0.0994 US dollars. And for memory hours, defining based on what you have defined it on, you need to pay this amount as well. And when it comes to this, if you make a hosted agent and you have 3 people who access that hosted agent at the same time, you're essentially spinning up 3 small virtual machines. And whenever they run, it costs this per hour. If one of the users don't use it for 15 minutes, it will shut down itself. So it's a little like Azure Functions. I treat it mostly as how Azure Functions work, in that if nobody is using your hosted agent, there is no cost other than the 15 minutes shutdown time. But if there's a lot, it will just scale up. This one will also automatically scale up. But there is a cost involved in this because they're essentially hosting your code. I don't have any of these in production, so I can't tell you exactly how much this is. But of course, if you have an AI that is used a lot, it will cost more because it's active 24/7. If nobody uses it, it shouldn't cost you anything. So at least it's not as bad as just a normal container apps that you pay for, no matter how if there's any users or not. I mentioned these 4. The last thing I just want to mention, just for reference, is there is a 5th option, and it's called persistent agents. But that was part of the old AI Foundry portal before Microsoft back in October 2025 renamed it to Microsoft Foundry, and prompt agents came along. So prompt agents came and took over. They are now called classic agents. They are still there, but you definitely shouldn't use them if you're going forward. You should use prompt agents. That's the closest to what the old persistent agents could do. So that is everything there is to say about Microsoft Foundry agents. I hope it made more sense what you can do now. Again, I still often go here, but I might want to try this out because it's a good way of, or cheap way of hosting, and Foundry agents if I need RBAC. But with that, thank you for listening and see you in the next one.